Bismillahirrahmanirrahim. In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum, dear students. Welcome you all in Pakistan International School Taif Virtual Learning System. Today is our 25th video lecture for grade second year students, boys and girls. I'm Mrs. Rosie Imran, your mathematics teacher. First 6 exercises of chapter number 2 we already done. I already discussed in our previous lectures. Today we will start exercise 2.7. Exercise 2.7. Here if you check in first question you have given that find y2. y2 means that the given function you differentiate twice. Once you differentiate you get the answer, that will be y1. Again you differentiate, then you get y2. y1 is the first derivative and y2 is the second derivative. So you have given y is equal to 2x power 5 minus 3x power 4 plus 4x cube plus x minus 2. So differentiate with respect to x. So what you get? dy by dx and derivative of this value, derivative of this given function. So you know that 2 is the coefficient, so first derivative is shown by represent by y1, and when you take the derivative of 2x power 5, so 2 as it is and x power 5, 5 will come in the coefficient and from 5 you subtract 1, so you get x power 4 minus 3 as it is, the coefficient as it is, the power will come in the coefficient and from power you subtract 1, you get x cube. 4 plus 4 as it is, the power will come in coefficient, from power you subtract 1, you get power 2. Here derivative of x is 1 because dx by dx equal to 1 and the constant derivative is 0. So what you get? y1, 5 2s are 10, 10x power 4, 3 4s are 12 minus 12x cube plus 4 3s are 12, 12x square plus 1. Now again you differentiate with respect to x because you have to find y2, means that twice you take the derivative of the given function. So dy1 divided by dx, derivative of this function 10x power 4 minus 12x cube plus 12x square plus 1. So this 10 as it is, the power 4 will come in the coefficient and from power 4 you subtract 1, so 4 minus 1 cube you will get. Minus 12 as it is, power will come in the coefficient and from power you subtract 1, so 3x square. And here 12 as it is, power will come in the coefficient and from power 1 you subtract, from power 2 you subtract 1, you get power 1. And the constant derivative 1 is 0. So what you get? 10 4s are 40, 12 3s are 36, 12 2s are 24. So this you get, this is the required answer. Here in the second part, if you check, in second part, you have given y equal to 2x plus 5 whole power 3 over 2. So when you differentiate with respect to x, so you get the power will come in the coefficient and from power you subtract 1, you know that, and then take the further derivative without power, derivative of 2x plus 5. This 3 over 2 as it is, 3 by 2 minus 1, you get 1 over 2 and derivative of 2x is 2 and derivative of 5 is 0. So we will not write, and here derivative of x is 1, so 2 ones are 2 you get. This 2 and this one 2, this is in the denominator, so they will cancel with each other. So you get 3 into 2x plus 5 1 over 2. So this is y1 first derivative. Now differentiate again with respect to x. This 3 is considered as coefficients. You write as it is. Again, the power will come in the coefficient, and from power you subtract 1. So 1 over 2 minus 1, so you get minus 1 over 2. And then further derivative of 2x plus 5. When you take further derivative of 2x, you get 2. And when you take the further derivative of 5, you will get 0. So 2 will come. This 2 and this one 2 cancel with each other, and 3 will come in the numerator, and minus 1 over 2 to make it positive shifted in the denominator. So positive 1 over 2, you know that that is equal to under root. So 3 over under root 2x plus 5 you get. Now come to the third part. In third part you have given y is equal to under root x plus 1 over under root x. So under root x you write it is x power 1 over 2, and under 1 over under root x is x power minus 1 over 2. When you shift it in the numerator, law of exponent, so power will become negative. Now differentiate with respect to x. The power will come in the coefficient 1 over 2, and from power you subtract 1, so minus 1 over 2 you get. And here again, for the second value, power will come in the coefficient minus 1 over 2 multiply with plus sign, so we get minus 1 over 2, and from minus 1 over 2 you get subtract minus 1, so you get minus 3 over 2. Now this is the first derivative, 1 over 2 x power minus 1 over 2 minus 1 over 2 x power minus 3 over 2. So again you differentiate with respect to x. This 1 over 2 is common in both, so you take it out and take the derivative of these two values. So here again minus 1 over 2 will come in the coefficient, and from minus 1 over 2 you subtract 1, you get minus 3 over 2. And here minus 3 over 2 will come in the coefficient, so minus minus plus 3 over 2, and from minus 3 over 2 you subtract 1, you get minus 5 over 2. Now to make this power positive, 1 over 2 is common again, so you take it out, so it will be 1 over 4. And here to make it positive, 1 divided by x power 3 over 2 plus 3 divided by x power 5 over 2. Now if you take the LCM, you get x power 5 over 2, and in the numerator minus x plus 3. So y2 is 3 minus x divided by 4 into x power 5 over 2. Come to question number 2. Again you have given find y2. Again you will take the double derivative, but here if you check, this is given in form of product, so you will apply the product rule, and this is given in form of natural log, so you know that natural log is 1 over that value and then further derivative of this. So differentiate with respect to x, we apply the product rule. The first term as it is, derivative of the second term, plus second term as it is, derivative of the first term. So x square e power minus x derivative is e power minus x, and further derivative of minus x is minus 1. Here e power minus x as it is, power will come, x square derivative power will come in coefficient, and from power subtract 1 to minus 1 power 1. Further derivative of x is 1, so no need to write. E power minus x is common, so you take it common, so you get minus x square plus 2x. Now again, differentiate with respect to x, because the question is that take the double derivative. So again the product rule, both values given in form of product. First value as it is, derivative of the second value, plus second value as it is, derivative of the first value. So this power 2 will come in coefficient, and from power we subtract 1, so minus 2x we get. And here 2 as it is, for derivative of x is 1, so 2 ones are 2. And here this one value you copy as it is, and derivative of exponential function we write as it is, and further derivative of its exponent minus x is minus 1. Now if you check, e power minus x is common. So you take x e power minus x common, so that is minus 2x plus 2, and this minus multiply with this minus plus x square, and plus cancel, multiply with minus minus. So minus 2x is minus 4x, x square plus 2. So this is the required answer. Now come to the second part. In second part, if you check, you have given y natural log of this value. You know that if it is given in form of fraction, so you know that natural log numerator minus natural log denominator. So differentiate with respect to x. So natural log of 2x plus 3 is 1 over 2x plus 3. Then further derivative without natural log, derivative of 2x plus 3. So 2x derivative is 2 and 3 derivative is 0. So 2 come. And then derivative of natural log of 3x plus 2 is 1 over that value, and further derivative of 3x plus 2. So 3 will come as it is, and constant derivative 0, and x derivative is 1. So 3 ones are 3. So this you get. You get 2 into 2x plus 3 power minus 1, 3 into 3x plus 2 power minus 1. Now differentiate with respect to x again. So when we take the differentiation, this coefficient 2 as it is, derivative of this term, minus 3 as it is, derivative of this term. Now power will come in the coefficient, and from power we subtract 1, so minus 2, and then further derivative without power 2x plus 3. So 2x derivative is 2 and 3 derivative 0, so 2 we write here. And minus 3, here the power will come in the coefficient, from power we subtract 1, so minus 2, and 3x plus 2 without power, its further derivative, 3x derivative is 3 and 2 derivative is 0, so 3. Now this 2 multiply with this 2, so 2 2s are 4, so minus 4 divided by, to make it positive we shift it in the denominator, 2x plus 3 power 2 plus 3 3s are 9, minus minus plus 9 divided by, to make it positive shifted in the denominator, 3x plus 2 whole square. Now if you want to take LCM, so you will take LCM, 2x plus 3 whole square and 3x plus 2 whole square. So when you take LCM, you will get this, and here you apply a plus b whole square formula, the first term square plus 2 into first term into second term plus second term square, and here again a plus b whole square formula, so first term square, it should be 2, it should be 2, by mistake it's written 3, it should be 2, so 2 square is 3. So that is, so 2 square is 4. Here it's not 3, it's by mistake written 3. You make it correct. This is 2, 2x plus 2. So 2x square is 4x square plus 2 into 2x into 3x, 12x plus 9. And this square will also not come. I tried to make it correct, but I don't think so that change is possible. Mm, here is the change in this. No, now it's not possible to change here, but I explain that how you will change. This value is here, the value in place of 3 you write 2, okay, because you can check it here, 2x whole square is 4x square, and this square is not present because you already take the square of the value. Now open the bracket. When you open the bracket, minus 4 multiply inside the bracket and you will get this value, and plus 9 multiply inside the bracket and you get this value. When you simplify, 8 plus 36x square minus 36x square cancel with each other, and from 108, when you subtract 48 you get 60x, and from 81 you subtract 16 you get 65. So this is the required answer. Now come to the third part. In third part, if you check, you have given y equal to under root 1 minus x 1 plus x. So you write it in form of power. power, then you solve it by yourself. How you solve? The power will come in the coefficient, and from power you subtract 1, and then you take further derivative of without power 1 minus x 1 plus x by quotient rule. You apply the quotient rule. When you apply quotient rule, when you solve, you get the first derivative, this. Then again you differentiate. When you differentiate, the power will come in coefficient, and from power you subtract 1. They are given in form of product. So the first term derivative, first term as it is, second term derivative my plus second term as it is, plus minus minus second term as it is, then the derivative of first term. When you simplify, you will get your answer. What you will do, again I'm going to explain. Look, here you have given in form of under root. So you write it in form of power. So you know that when you take the derivative, the power 1 over 2 will come in the coefficient, and from power 1 over 2 you subtract 1. So you get minus 1 over 2 in power. Then without power, you take the further derivative of 1 minus x, 1 plus x. How? By taking quotient rule. With the help of quotient rule, the denominator square, then the denominator, in numerator what you write, the denominator value, derivative of the numerator value minus numerator derivative of the denominator value. Like this you will solve, and when you simplify, you will get this answer. Now both are given in form of product. Then you apply the product rule. First term as it is, derivative of the second term, plus second term as it is, derivative of the first term. Remember one thing, if any value having some power, so first you apply the power rule. Power will come in the coefficient, and from power you subtract 1. And then you take the further derivative without power. Okay, so try to solve this third part by yourself. Okay, inshallah, question number 4 we will discuss in our next video lecture. So if any problem, any question related to this exercise or this chapter, this is a lengthy chapter and having so many exercises, and very important, mostly question come in paper from this chapter. So inshallah, within 2-3 lecture I'll complete this chapter, and then we will start chapter number 3. So take care. Allah Hafiz.